Hello student, very good morning to everyone. Hello, good morning or good afternoon? Good afternoon. Okay, okay, so good afternoon to everyone. These are the okay. So these are the points that okay. So what these are the points that we had learned in the last lecture. Now it is clear. Hello. Okay. Okay. Check your internet connection because I don't. I think my end I okay. These are the points that we are learning in the last lecture, that is meso compound or a meso structure. ठीक है. So meso compound means what? A molecule with two or more chiral carbon atom but have a plane of symmetry is called as meso structure or a meso compound. So the compound that having more than two chiral center, okay, and that molecule passes the plane of symmetry, that compound is called as meso compound or meso structure. So these are the example of meso compound or meso structure. So this structure having two chiral center, this one and this here second chiral center. So and it passes the plane of symmetry. So these are the examples of your meso structure, because this molecule having more than two chiral center or one or two chiral center, but it passes the plane of symmetry. So this molecule passes the plane of symmetry although it having two chiral center. So this molecule is called as meso compound or a meso structure. ठीक है. So these meso compounds are optically inactive, and you know that the optical inactivity of the meso compound is due to internal compensation, because the problem is in your structure, it passes the plane of symmetry. That's why these meso compounds are optically inactive. So this meso compound, it is a single compound which is optically inactive even though it has a two or more chiral center, and it passes the element of symmetry, that is plane of symmetry, and the optical inactivity of this meso compound is due to internal compensation. Then again in the last lecture we had learned this racemic mixture. So the racemic mixture means it is a mixture of equal parts of enantiomer. Equal parts of enantiomer is called as racemic mixture or a racemic modification, and it is also called as equimolar mixture of plus and minus form of compound, that is called as racemic mixture. So this racemic mixture, it is again it is optically inactive, and the optical inactivity of this racemic mixture, it is due to external compensation, because racemic mixture contain two enantiomer. It means that one rotate on right hand side and one rotate on left hand side. That's why the net effect is zero. That's why this racemic mixture are optically inactive, and it cannot be separated by physical method, but it can be separated by chemical method, and the name of that method is resolution. Name of that method is resolution. So students, again in the last lecture we have learned the difference between your meso compound and racemic mixture. So first difference between is in racemic mixture, it is equimolar mixture of two enantiomer, that is plus and minus form, while meso compound, it is a single compound with two or more chiral carbon atom but has a plane of symmetry, but it passes plane of symmetry. That compound is called as meso compound. And this racemic mixture, it can be separated by method called as resolution, and this meso compound, it can't separate because it's a simple compound, single compound. Then this racemic mixture, it doesn't passes any element of symmetry, while this meso compound, it passes the plane of symmetry. Then the next difference between is this racemic mixture are optically inactive, and the optical inactivity of this racemic mixture is due to external compensation, because you are having equimolar mixture of two enantiomer. It means that one rotate on right hand side and other rotate on left hand side, and the net effect is zero. So this is the reason behind the optical inactivity of racemic mixture. While this meso compounds are also optically inactive, but the optical inactivity is due to internal compensation. The optical inactivity of a meso compound is due to internal compensation because it passes the plane of symmetry. And in the last to last lecture we have learned the element of symmetry, that is the any molecule which passes plane of symmetry, center of symmetry, or a alternating axis of symmetry, that molecule will be optically inactive. So this is what we had learned in the last lecture. So students, again in the last lecture we had learned the resolution. So resolution means what? It is a separation of racemic mixture. It is a separation of racemic mixture into two individual optically active components, that is plus and minus form, is known as resolution. So resolution, it is one of the method by which you can separate the racemic mixture. You can separate the racemic mixture into two individually optically active components, that is called as resolution. So consider this beaker contain what? Your racemic mixture, and by this method resolution you are separating this into plus and minus form. This is simply called as resolution. This is simply called as resolution. Okay, so this is the just a revision that what we had learned in the last lecture. Now students, today I am going to teach you the relative configuration. And this relative configuration, it is also called as the D and L nomenclature. It is also called as D and L nomenclature. So first we'll see what is configuration. So configuration means the arrangement of atom that characterizes the particular stereoisomer. The arrangement of atom that characterizes the particular stereoisomer is called as configuration. So in D and L nomenclature, this is the method that is used for the assigning the configuration of carbohydrates and protein. So this D and L nomenclature is used to, or it is used for the assigning the configuration of carbohydrates and protein. So here in this D and L nomenclature, glyceraldehyde. So this is the structure of your glyceraldehyde. This glyceraldehyde is arbitrarily chosen as a standard. So here in D and L nomenclature, we are using glyceraldehyde as a standard, and so here is a structure of your glyceraldehyde. Now look at this structure carefully. So it having this chiral carbon CHO group, that is aldehyde group. Then this it having OH group, hydroxy group, hydrogen, and CH2OH group. Now when this OH group present on right hand side, okay, so this OH group, when I see this structure from my point of view, okay, this OH is on my right hand side. If the OH group present on right hand side, that is called as D-glyceraldehyde. OH is on right hand side, that is called as D-glyceraldehyde. Now look at this second structure, okay. So here the simply OH group present on left hand side, okay, OH group present on left hand side, and this is called as L-glyceraldehyde. L for left hand, and you have to consider D for right hand. So in D and L nomenclature, what you have to do is that just you have to see the structure, okay, and if the OH group present on right hand side, that may be D compound, and if that OH group is present on left hand side, that is L compound, okay. So this is the simple way to put a, okay. So here is your, okay, so you have to okay, here is your left hand side, okay. So by what copy pasting it, one mistake is there. So just what, this OH is on left hand side. If this, now you have to correct this mistake, this is your what, right, this is your what, left hand side, okay. So now this D and L nomenclature is very simple, okay. By giving this D and L nomenclature, just you have to see the structure. If that in the structure, if the OH group present on right hand side, that is your D compound or D molecule, and if the OH group or a hydroxy group present on left hand side, that is your L compound. So here OH is on left hand side, OH is on left hand side, so it's a L. And here the OH is on right hand side, OH is on right hand side, it's a D-glyceraldehyde and it's a L-glyceraldehyde. So this is the simple, and it is called as the relative configuration. It is called as the relative configuration. So D and L nomenclature is called as relative configuration. Okay. So this method is used to nomenclature the carbohydrates and protein. Now let's move towards the next slide. Now this D and L nomenclature can also be used for the compound that having this type of structure: chiral carbon R, R dash, X and H, chiral carbon R, R dash, R, and not applicable to this type of compound. If all are alkyl group, then that time this D and L nomenclature will not be applicable for such type of compound. Now here this X is equal to hydroxy group NH2, or it may be halogen, that is fluorine, chlorine, bromine or iodine. Now here if this X if it is present on right hand side, that is D compound. So here this X is present on right hand side, so it's a D compound. Here same, this X is present on right hand side, so it's a D compound. And X is equal to X may be OH, NH2, halogen, that halogen may be fluorine, chlorine, bromine or iodine, fluorine, chlorine, bromine or iodine. Now here in this structure, this is your X is equal to NH2. So here this NH2 present on right hand side. Here the what? This NH2 present on right hand side. So it's a D. Okay, the configuration of this molecule is D. While in this second compound, this NH2 group present on left hand side. This NH2 group present on left hand side. So it's a L. Simply left, if it is present on left hand side, okay, means you have to write L for left hand side, okay, and D for right hand side. So here in the third compound, this NH2 group present on your left hand side, so it's a L compound. Here this your bromine present on right hand side, it's a D compound. So this is the simple method to give the nomenclature to the compound, whether it is D or L. Okay, so this D and L nomenclature can also be give to this type of compound. Okay, so here this X is equal to, it may be a hydroxy group, it may be NH2 group, amino group, or it may be fluorine, chlorine, bromine or iodine. Okay, so just what you have to see is that just you have to see the X is equal to OH, NH2 or halogen. If that X is present on right hand side, that is your D molecule, D compound. And if that X is present on left hand side, that is your L. So here NH2 present on right hand side, it's a D. Here NH2 present on left hand side, it's a L. Here NH2 present on left hand side, it's a L. And in this structure here, bromine is present on right hand side, so it's a D. So this is the simple method to give the nomenclature, whether it is D or L. Okay, so the question may be asked in your examination. 2-3 compounds are given, and the question may be asked, which of the following having D configuration? Okay, so just have to find out X, if that X present on right hand side, so it's a simply D, and if it is present on left hand side, it's a L. Now the next point that I'm going to teach you, that is your absolute configuration, and this RNS nomenclature is called as absolute configuration. RNS nomenclature is called as absolute configuration. So the chiral carbon atom are assigned as R and S, and this RNS nomenclature, it is also called as can, Ingold and Prelog rule, that is CIP rule. Can, Ingold and Prelog rule, CIP rule. So enantiomer can be named as R and S isomer by using Can, Ingold and Prelog rule, named after three scientists who devised them. So these are the three scientists who discovered this rule. So assignment of configuration is done by the sequence rule. So assignment of configuration, whether it is R or S, it is done by the sequence rule. Okay, and in sequence rule what we are doing is that the sequence rule arrange the group of chiral center in a priority sequence. In a sequence rule, what you are arranging the group in a priority sequence. So so you are giving the priority to the 4 group which is attached to chiral carbon. So this is your chiral carbon, and these are the 4 groups which are attached to this chiral carbon, and you are giving the priority. You are giving what? Priority depending upon its atomic number. You are giving the priority depending upon its atomic number, and the atom which have highest atomic number, that atom will get highest priority. So first is your highest priority, like this: first, second, third, fourth. So you are having only 4 group, so you are giving only 4 priority: first, second, third, fourth. And first is your highest priority, second is your lowest priority, third, and then fourth. Then you are ignoring the 4th priority group, and you are what? Ignoring the you are ignoring the 4th priority group. So here first, second, third, first, second, third. So it rotate what? It rotate clockwise. It rotate what? Clockwise. First, second, third. First, second, third. It rotate clockwise. It means that it having R configuration. This chiral carbon having R configuration because it rotate first, second, third clockwise. So it's a R configuration. If it rotate anti-clockwise, first, second, third, so it's a anti-clockwise direction. It's anti-clockwise rotation. First, second, third, first, second, third, fourth. You are ignoring the 4th group, so you are only seeing first, second, and third. Only 3 groups. So first, second, third. So it rotate anti-clockwise. It rotate anti-clockwise. It means the configuration of this carbon is S. So this S and R, these are the Latin word. R means rectus, which means right hand side, and S means sinister, which means left hand side. So this is just what a sequence rule. Okay, so arrange the 4 in what? In this, what you are doing, the sequence rule arrange the group of a chiral center in a priority sequence, that is 1 2 3 4. First is the highest priority and fourth is the lowest priority. So you have to ignore the 4th priority group. चौथा ग्रुप तुम्हाला इग्नोर करायचा आहे. ठीक आहे. Then if the arrangement that is 1 2 3, if the arrangement that is 1 2 3 it is clockwise, then it is R configuration, and if the arrangement that is 1 2 3 it's anti-clockwise, that means that carbon having S configuration. Okay, so S, it is a Latin word, means sinister, right hand side, and rectus, it is a Latin word, means right hand side. Now let's see what is sequence rule. Okay, what is sequence rule? So 4 rules are there: 1 2 3 4. So we'll see one by one. What is rule 1, what is rule 2, what is rule 3, and what is rule 4. Okay, so you can easily understand what is sequence rule. So in rule 1, what you are doing is that arrange the 4 group. It's not a far, it's a 4 group. Arrange the 4 group around the chiral center. Arrange the 4 group around the chiral center in order of priority. In order of priority. Priority is based on the descending order of atomic number of linking atom of a group. Atom of highest atomic number get highest priority. Okay, so to understand the rule number one, let's take this example. So this is your chiral carbon. Okay, so these are chiral carbon, and to this chiral carbon, this bromine, carbon, chlorine and hydrogen are attached. So these are the four different groups which is attached to this chiral carbon: bromine, CH3, chlorine and hydrogen. Now you have to give the priority order. What you have to do is that you have to give the priority order. So atom with the highest atomic number get highest priority. So among these four, bromine, carbon, chlorine and hydrogen. Okay, so bromine having highest atomic number, bromine having highest atomic number, atomic number of bromine is 35. Okay, so bromine will get first priority order, bromine will get first priority order. Then now remaining these three, okay, hydrogen, carbon and chlorine. Okay, so the atomic number of carbon is 6, chlorine is 17. Okay, so now second priority goes to chlorine. So we are labeling this chlorine as the second priority. Now carbon and hydrogen. So carbon having atomic number 6. So this CH3 methyl group will get third priority. So it will get third priority. And last is your hydrogen having atomic number 4. So hydrogen will get fourth priority order. So this is your rule number one. Okay, what you have to do is that you have to give the priority order to the atom which is attached to that chiral carbon depending upon its atomic number. The atom with highest atomic number, that will get highest priority order. Okay, highest priority means first is your highest priority, second lowest, third lowest and fourth is lowest. Okay, so among these four, bromine having atomic number 35, so bromine will get first priority order. Then chlorine atomic number is 17, so chlorine will get second priority order. Now among these three among these two, that is methyl group and hydrogen, hydrogen having atomic number 1 while the carbon having atomic number 6. So this carbon will get third priority and hydrogen will get lowest priority order, that is 4. So we have given the priority order: bromine first, chlorine second, methyl 3 and hydrogen fourth. Okay, so depending upon its atomic number we have labeled this: bromine first priority, chlorine second, methyl 3 and hydrogen 4. Now we have to see the rotation. Okay, you have to ignore the fourth group, याला आपण इग्नोर करतोय. Now we have to see the sequence 1 2 3 only, 1 2 3. So this is your 1. Now it said 2 and 3, 1 2 3, 1 2 3, 1 2 3, 1 2 3. It means that this rotate anti-clockwise, this rotate anti-clockwise, and the configuration of this carbon is S configuration because it rotates anti-clockwise. So you have to write S configuration and anti-clockwise, and you have to see only three sequence: first, second. You have to see the only three numbers, that is first, second and third. And here first, second, third, it rotating in a anti-clockwise direction. So this carbon having S configuration. Okay, this carbon having S configuration. So this is your rule number first. Now let's see rule number second. That is sequence rule 2. So in this rule number 2, okay, if two linking atoms are same, then consider the atom next to it and follow the rule number 1. Okay, so to understand this rule number 2, let's take this example. Okay, so this is your chiral carbon, and to this chiral carbon these are the four group attached: bromine, CH3 and C2H5 and hydrogen. Okay, now this chiral carbon attached to directly to bromine, hydrogen, CH3 and C2H5. Now this chiral carbon attached to same atom, that is carbon and carbon, both the linking atom are same. Then this rule number second says that if two linking atom are same, then consider the atom next to it. Okay, then you have to consider the atom, what are the atom that is attached to this same atom. Okay, so we are giving the priority order. So among these four, bromine, carbon and hydrogen, bromine having highest atomic number. Okay, so bromine will get first priority order, first 35 first. See, bromine first priority order. Now these are the now we have to give the priority order between this CH3 methyl group and ethyl group, CH3 and C2H5, so that both the joining atom are same, that is carbon and carbon, both the carbon having same atomic number, carbon 6 carbon 6. Now we have to consider the next atom which is attached to that carbon. Okay, so to this CH3 group, three hydrogens are attached, carbon and three hydrogen. So this your methyl carbon is attached to three hydrogen. So carbon having atomic number 6 and plus it having three hydrogen, 6 plus 3 9. Okay, now we have to see this C2H5 group. Now the linking atom is same, so we are seeing the next, what are the atom attached to that carbon. Okay, so this carbon is attached to again one carbon has to again one carbon and 5 hydrogen, one carbon and 5 hydrogen. Okay, so one carbon and 5 hydrogen. Okay, now we have to calculate the atomic number of CH3 and C2H5. So first we'll calculate the atomic weight of this CH3, carbon 6, and this carbon is attached to 3 hydrogen, atomic number of carbon is 6, and plus it having 3 hydrogen, 6 plus 3 9. Now this we have to calculate this molecular weight of this C2H5. So this C2H5 it having 2 carbon. Okay, 2 carbon means atomic number 6 plus 6 12, and it having 5 hydrogen. So atomic weight of this C2H5 is 17. So among these two, CH3 and C2H5 will get second priority order. C2H5 will get second priority order because it having highest atomic weight. Okay, molecular weight. So 17 C2H5, CH3 3, and hydrogen having atomic number 4. So hydrogen will get fourth priority order. So first, second, third, fourth. First, second, third, fourth. So bromine having atomic number 35. So bromine will get first priority order. Now C2H5 will get second priority order. CH3 will get third priority order, and your hydrogen will get fourth priority order. Now you have to see the rotation. Now what? You have to see the rotation. First, second, third. First, second, third. So it rotate anti-clockwise. First, second, third. It rotate anti-clockwise, and the configuration of this carbon is S. The configuration of this carbon is S because it rotates anti-clockwise. Because it rotates what? Anti-clockwise. So this is about your rule number 2. In rule number 2, what you are doing is that if the two linking atoms are same, then consider the next atom to it. Okay, so simply to understand this, let's take this molecule. Okay, so this is your chiral carbon, and this chiral carbon attached to bromine, methyl group, ethyl group, and hydrogen. Bromine, methyl group, ethyl group, and hydrogen. So bromine having highest atomic number, bromine will get first priority. Then we have to find out the priority order between this methyl and C2H5. So simply this methyl group is attached to carbon and 3 hydrogen, and here this ethyl group attached to 2 carbon and 5 hydrogen. So this C2H5 will get second priority order, and this methyl group will get third priority order. Now we have labeled this group first, second, third, and fourth. First, second, third, fourth. Now we have to see the rotation. First, second, third. First, second, third. So it rotates in a anti-clockwise direction. It rotates in a anti-clockwise direction, and the configuration of that chiral carbon is S. Configuration of that chiral carbon is S. So this is about rule number 2. Now let's see rule number 3, sequence rule number 3. So here it talks about the isotope. It talks about the isotope. If two linking atom are isotope, if the two linking atom are isotope, then the isotope with highest mass number gets the highest priority. If the two linking atom are isotope, then the isotope with highest mass number will get the highest priority. So to understand this rule number 3, let's take this example. So this is your chiral carbon, and this chiral carbon attached to your methyl group, and this is your deuterium, tritium and hydrogen. So this deuterium, tritium and these are the isotopes of hydrogen. Okay. So isotope the hydrogen having 4 isotope, 3 isotope, hydrogen having 3 isotope, hydrogen, deuterium and tritium. Okay, so hydrogen having 1 mass number, deuterium having 2 and tritium having 3 mass number. So rule number 3 said that if two linking atom are isotope, then the isotope with highest mass number, that isotope will get highest priority. Okay, so these are the, so this is your chiral carbon, and to this chiral carbon this methyl group, hydrogen, deuterium and tritium is attached. Now we have to give the priority order. We have to give the priority order to these 4 atom or 4 groups attached to this chiral carbon. Okay, so to this chiral carbon, carbon, deuterium, tritium and hydrogen is attached. Okay, to this chiral carbon, carbon, deuterium, tritium and hydrogen is attached. So here among these 4, this carbon having atomic number 6. Carbon, first you have to see the first atom. What you have to see the first atom. So this carbon having atomic number 6, so methyl group will get first priority order. So this CH3 carbon having atomic number 6, so what, this methyl group will get first priority order. Now these are the two isotope, these are the isotope, deuterium and tritium, these are the isotope. Okay, isotope of hydrogen. So this tritium having mass number 3, deuterium having mass number 2 and hydrogen having mass number 1. So this tritium having highest mass number, so tritium will get second priority order. Tritium will get second priority order. First, second. Now among these two, deuterium and hydrogen, deuterium having mass number 2, so deuterium will get third priority order. Deuterium will get third priority order, and hydrogen will get fourth priority order. Now you have labeled, now you have given the priority order: first, second, third, first, second, third. Now it rotate anti-clockwise, it rotate anti-clockwise, and the configuration of this carbon is S. Configuration of this carbon is S. So this is about your sequence rule number 3. So this rule number 3 says that if the linking atom are isotope, if the two linking atom are isotope, then the isotope with highest mass number, the isotope with highest mass number will get highest priority order, will get highest priority order. To understand this rule, let's take this example. Okay, so this is your carbon, this chiral carbon attached to methyl group, hydrogen, tritium and your deuterium. So among these 4, carbon, deuterium, hydrogen and tritium, carbon having atomic number 6, it having highest atomic number, so methyl group will get first priority order. Methyl group will get first priority order. Okay, so we have labeled first. Now among these 3, hydrogen, deuterium and tritium, tritium having mass number 3, it having highest mass number, so tritium will get second priority order. Tritium will get second priority order. Now among these two, deuterium and hydrogen, deuterium having mass number 2, so deuterium will get third priority order, and hydrogen will get fourth priority order. Now you have to see the rotation: first, second, third, first, second, third. So it rotate anti-clockwise, and the configuration of this chiral carbon is S. If it rotate right hand side, so it's R. So now it rotate in a anti-clockwise direction, so it's a S configuration. If it rotate clockwise, then it's a. So this is about your rule number 3, sequence rule number 3. Now let's see let's see rule number 4. Rule number 4. So this rule number 4 said that group containing double bond or triple bond, any group having, or any group if it contain double bond or a triple bond, are assigned as both. So here 7 is not there. Assigned priority as both. So so the group containing double bond or a triple bond are assigned as both the atom were duplicated or replicated. Okay, so if double bond is there, then you have to duplicate that, and if triple bond is there, then you have to triplicate that. So suppose if you are having carbon carbon double bond, you have to assume that carbon is attached to again one carbon, and this carbon is attached to again one carbon. So this is called as duplication. If double bond is there, you have to duplicate that. And if triple bond is there, let's take this example: C triple bond N, cyanide, C triple bond N. So if this triple bond is there, then we have to triplicate that. So we have to assume that this carbon is attached to 3 nitrogen. Same here, this carbon carbon triple bond is there, so we have to assume that this carbon is attached to again 3 more carbon. Okay, if double bond is there, then we have to assume that this carbon is attached to 2 more oxygen. Same, double bond is there, we have to assume that this carbon is attached to 2 more carbon. So this is called as duplication and triplication. So to understand this, what is duplication, triplication, let's take this example. Okay, so this is your chiral carbon, and this chiral carbon attached to C triple bond N, NH2, C triple bond CH, and OH. So this chiral carbon attached to first atom carbon, nitrogen, carbon, and oxygen. This chiral carbon attached to carbon, nitrogen, carbon, and oxygen. Now among these 4, carbon, nitrogen, oxygen. Okay, so oxygen having highest atomic number. Oxygen, this OH group having highest atomic number. So OH will get first priority order. You have to see the first atom. And the first atom which having highest atomic number, that atom will get first priority. So carbon, nitrogen, oxygen, and carbon. Oxygen having atomic number 8, so OH will get first priority, and nitrogen having atomic number 7, so NH2 group will get second priority order. Now now here is your, both the joining atom are same, carbon carbon, C triple bond and C triple bond CH. Okay, now if double bond and triple bond is there, here triple bond is there, now we have to triplicate that. Okay, so this is your carbon nitrogen triple bond, and we are triplicating that carbon nitrogen triple bond like this. We are assuming that this carbon is attached to again 3 more nitrogen. Same, this carbon carbon triple bond, we are assuming that this carbon is attached to 3 more carbon and hydrogen. Now once you have done the triplication, you have to calculate the molecular weight of that particular group. You have to calculate the molecular weight of that particular group. So let's calculate the molecular weight of this C triple bond N. Okay, C triple bond N. So in C triple bond N, now we are calculating the molecular weight. Okay, so here this carbon having atomic number 6, and to this carbon 3 nitrogen are attached, and each nitrogen having 7 atomic number. So 6 plus 7 plus 7 plus 7. Okay, so the total is 27. And now we have to calculate the molecular weight of this C triple bond H. So carbon having atomic number 6, and to this carbon again 3 more carbon are attached. Okay, 6 plus 6 plus 6 plus 6 and plus 1 for hydrogen. Okay, so when you calculate the molecular weight of this C triple bond C, this 4 carbon and 1 hydrogen, its molecular weight is 25. Okay, so this C triple bond N having highest molecular weight as compared to C triple bond CH. So C triple bond N will get third priority order, and C triple bond CH will get fourth priority order. So now we have given the priority order: first, second, third, fourth. First OH, oxygen having atomic number 8, so OH will get first priority order. Now nitrogen having atomic number 7, so this NH2 will get second priority order. Now these are the two same atom. Okay, so we have to calculate the molecular, you have to do the triplication and calculate the molecular weight of this particular group. Okay, so by calculating the C triple bond N having 27 and C triple bond CH having 25, so for C triple bond N will get third priority order, and the C triple bond CH will get fourth priority order. It will get fourth priority order. So now now what you have to see the rotation. You have to see the rotation: first, second, third. You have to ignore the fourth group. आपण हा ग्रुप घेत नाही. We are ignoring this. ठीक आहे, we are ignoring the fourth group. So first, second, third. So it rotating in a anti-clockwise direction. And the configuration of this chiral carbon is S. So these are the 4 rules which are used for the absolute configuration, and R and S nomenclature is also called as absolute configuration. ठीक है, so this is it's about that. हाँ बोला रे, किसका? हाँ हाँ हे बघा आता. हाँ हाँ आता ठीक आहे. आता बघ, आपल्याला काय करायचं, फर्स्ट रूल फॉलो करायचा आहे. ठीक आहे, हा तुझा कायरल कार्बन है. ठीक है, इस कायरल कार्बन को पहला एटम जो अटैच होता है उसका एटॉमिक नंबर देखना है हमें. जिसका एटॉमिक नंबर ज़्यादा है उसको ज़्यादा प्रायोरिटी देनी है. ठीक है, सो दिस कार्बन अटैच टू ऑक्सीजन एंड नाइट्रोजन. ठीक है, एंड कार्बन ऑक्सीजन, nitrogen, carbon and carbon. So among these 4, ऑक्सीजन, नाइट्रोजन, कार्बन, ऑक्सीजन का एटॉमिक नंबर ज्यादा है. पूरा नहीं कैलकुलेट करना है, पहले हमें क्या करना है, सिर्फ पहला एटम देखना है, और पहले एटम का जिसका एटॉमिक नंबर ज्यादा है उसको फर्स्ट प्रायोरिटी दे देना है. ठीक है, सो ऑक्सीजन का एटॉमिक नंबर क्या है, 8 है, और नाइट्रोजन क्या है, 7 है, कार्बन का क्या है, 6 है। सो हमें इन दोनों में से ऑक्सीजन की फर्स्ट प्रायोरिटी आएगी क्योंकि उसका एटॉमिक नंबर है फर्स्ट, एटॉमिक नंबर है 8, सो OH विल गेट फर्स्ट प्रायोरिटी, ठीक आहे. आणि नायट्रोजनचा ॲटॉमिक नंबर 7 आहे म्हणून नायट्रोजनला सेकंड प्रायोरिटी. नाव हियर टू लिंकिंग ॲटम आर सेम अँड इट हॅव्हिंग ट्रिपल बॉन्ड, यू हॅव टू डुप्लिकेट दॅट, ठीक आहे. नाव हियर यू हॅव टू यूज युअर रूल नंबर 2, ठीक आहे. रूल नंबर 2, you have to calculate the molecular weight. First you have to triplicate that, then you have to calculate. ओके, अगर इसका कैलकुलेट किया तो इससे ज़्यादा आएगा, 9 से ज़्यादा आएगा, बराबर. लेकिन द फर्स्ट जॉइनिंग एटम इज कार्बन कार्बन, ठीक है. दैट्स वाई दिस OH विल गेट फर्स्ट प्रायोरिटी बिकॉज द फर्स्ट एटम, इस कायरल कार्बन को फर्स्ट एटम ऑक्सीजन अटैच है, इसके लिए OH विल गेट फर्स्ट प्रायोरिटी. एंड दिस to this chiral carbon the first atom is nitrogen, ठीक है. So that's why nitrogen will get second priority. Now these are the two same linking atom, carbon and carbon, ठीक है, and it having the triple bond, then that's why we are triplicating that, and after triplicating we are calculating its molecular weight and then we are giving its priority. okay, so यहाँ तक ठीक है. अभी ये C ट्रिपल बॉन्ड का कैलकुलेट किया हमने, 27 आया, तो अभी इसको मिलेगा थर्ड प्रायोरिटी, और इसका जो C ट्रिपल बॉन्ड CH का फोर्थ आया, इसका 25 है तो इसको फोर्थ प्रायोरिटी. देन वी हैव टू सी द रोटेशन, ठीक है. सो दिस इज अबाउट योर सीक्वेंस रूल. सो दिस RNS configuration, it is also called as your absolute configuration, ठीक है. सो दिस इज about your relative and absolute configuration. In relative configuration you are taking the glyceraldehyde as a standard, and in that glyceraldehyde if what your OH group present on right hand side, then that your amino acid or carbohydrate may be D, and if that OH group present on left hand side, that amino acid or protein or carbohydrate will be what your L compound, ठीक है. then आता आपण सायनाइडचा मॉलिक्युलर वेट कॅल्क्युलेट केलाय पूर्ण टोटल. C ट्रिपल बॉन्ड आहे त्याला ट्रिप्लिकेट केलं आपण, ठीक आहे. हा कार्बन ट्रिप्लिकेट केल्यानंतर हा कार्बन आपण ॲझ्युम केलं की 3 नायट्रोजनला अटॅच आहे, बरोबर. कार्बनचा ॲटॉमिक नंबर 6 आणि नायट्रोजनचा 7 + 7 + 7, बरोबर. 27 झाले म्हणून आपण 27 लिहिले का, ठीक आहे. कार्बन 6, ठीक आहे, 7 + 7 + 7 म्हणून 27 लिहिलं इकडं. हो का, हा मग कार्बनचा ॲटॉमिक नंबर 6च आहे, 6च आहे. ॲटॉमिक नंबर नाही म्हणतात त्याला, त्या मॉलिक्युलर वेट म्हणता येईल. त्या ग्रुपचा मॉलिक्युलर वेट तेवढा आहे ग्रुपचा. C ट्रिपल बॉन्डचा 27 आहे. हां, म्हणजे पूर्ण ग्रुप C ट्रिपल बॉन्ड एन, म्हणजे आपण असं ॲझ्युम केलं की हा C ट्रिपल बॉन्ड म्हणजे कार्बन आणि त्याला 3 नायट्रोजन आहे, आणि ह्याचं पूर्ण टोटल हा 27 आहे, ठीक आहे. आणि हे C ट्रिपल बॉन्ड Cचा 25 आहे. So this is about your sequence rule number 4. Any doubt? नेक्स्ट लेक्चर आपण डिटेलमध्ये एक्झाम्पल घेऊ ना, जास्त म्हणजे पूर्ण लेक्चरला आपण एक्झाम्पलच घेणार आहे. त्या एक्झाम्पल मग आपण नंबर ऑफ एक्झाम्पल घेतले, मग तुम्हाला डिटेलमध्ये समजेल ते, ठीक आहे. आता कसं जस्ट आपण पहिल्यांदाच करतोय ना, पहिला थोडा प्रॉब्लेम येईल तुम्हाला. रोल नंबर कोणता, कशाचा, तू रोल नंबर 3. रोल नंबर कशाला पाहिजे रे तुम्हाला, थांब 1 मिनिट.